Greetings to all. In today's session, we are going to discuss about the intermediate chemistry on the international floor, which is helpful for the international entrance and competitive examinations as well. JEE Advanced, JEE Mains examination, NEET chemistry, which is a medical entrance examination on all India level. And next is about Telangana EAMCET, Andhra Pradesh EAMCET examination. For all these, the kind of explanation whatever we are providing will very much helpful. Apart from this, the people who ever preparing for any competitive examination, the part of questions whichever discussed will helpful for the cracking of your aspiring job. Let's enter into our question number 1. Here, which diagram shows the structure of an alloy? This is the compound provided where you can find hexagonal structures which are represented in the hexagonal manner, and the chair form is also mentioned. Again, you can say this is also hexagon, right? And the second kind of compound where all the atoms are arranged in the regular systematic arrangement, crystalline arrangement is provided, and all the atoms are represented with the same kind of sign, so that we can say all are homo, means the same kind of metal atoms, right? And in the third one, hexagonal layered arrangement you can observe, and this is the diagram. This is the structure which is given for graphite geometry. Graphite is having lubrication property, though it is the solid compound. That is because of this hexagonal geometry with the layered arrangement. So sliding nature is provided for graphite. That is option number C. Then alloy. Alloy means what? Mixture of metals present called alloy. Here, if you see, so one of the compound, one of the atoms are having one kind of geometry, and this is the atom with the another kind of geometry, so that we can say it is the mixture of metals. Mixture of metals is called alloy. So option number D will be the correct explanation for question number 1. Let's see what is meant by pure metal, what is alloy. Atoms are same size and shape present. If you see this, all the atoms are of same kind, that is called a pure metal. All pure metals are having layers and slide easily, and all these are said to be malleable. Malleable in the sense, if you hammer that can expand. So that is called malleability of metal. And if you take the alloy, alloy means different atoms of different sizes got combined. If you see this, one kind of atoms indicated with the blue lobes, and another kind of atoms indicated with the red lobes. So that mixture of atoms are there, and the size is not same for all kind of atoms whichever present in this. And compared to pure metal, here alloy will be taken as the harder material, and alloys are stronger when compared to pure metal. So that if you take the steel is the combination of iron and carbon that will impart the strength to that steel, right? In this manner, alloy always stronger, tough material, so that alloy is taken with the different atomic arrangement that is given in the option number D. For question number 1, option number D will be the right answer. Let's go with the question number 2. Methane burns in oxygen to produce the carbon dioxide and water. Methane burning with oxygen, carbon dioxide and water will be generated. Balanced equation to be depicted. Here, methane is denoted with the CH4, and oxygen if taken, so 2 moles of oxygen required to burn 1 mole of methane, so that we will get oxidized product. Combustion products will be generated. One is carbon dioxide, another is water. Being 4 hydrogens are accompanied with the carbon, so that 2 moles of water will be released during the reaction. This will be the balanced equation. Let's see. Methane with the carbon and 4 hydrogen atoms, and 2 moles of oxygen, so that indicated with the 2 moles of oxygen like this, so that oxygen will combine with the carbon as a carbon dioxide like this. So that is a linear molecule, can be clearly indicated. And another 2 molecules are bent water molecules. Bent water molecules are indicated 2H2O. This is the exact balanced equation for question number 2. For question number 2, option number B will be the correct answer. Let's go with the question number 3. This is the recent NEET 2023 examination question and medical entrance in the India level. The stability of copper plus 2 is more than copper plus 1 salt in aqueous solution due to, right? So copper plus 2 is more stable when compared to copper plus 1 salt under aqueous conditions. What could be the reason? The correct explanation will be hydration energy, right? Hydration energy in the sense whenever water molecules added, the energy emitted is called hydration energy. Greater the hydration energy, greater will be the stability of the compound. Why copper plus 2 is having higher hydration energy, subsequently higher stability? Let's see. This is about the neutral copper. Whenever copper lost one electron, you can get copper plus 1. By losing 2 electrons, copper plus 2 will be generated, right? So metallic copper is having this kind of neutral nature where radius is assigned with the 145 picometers, right? So whenever one of the electron lost, we will get cuprous. Cu plus 1 is called cuprous, and this cuprous metal ion is having 91 picometers radius. Ionic radius is accorded as 91 picometers. Whenever copper plus 2 will be there, copper plus 2 metal ion is having 73 picometers. As the charge increases, size of the cation shrinks. Size of the cation will concised, so that compared to metallic copper, copper plus 1, copper plus 2 is having smaller the radius with 73 picometers of size. And the conclusion is smaller the size, greater will be the hydration energy. Smaller cations are able to have higher charge density around them and having higher absorbability of water molecules, so the greater the extent of hydration energy, so that stability of that molecule also rises. So for question number 3, option number 2 will be the option number B will be the correct explanation. Let's go on with the question number 4, right? Here column 1 and column 2 are provided, and being it is the question given from biomolecules, and we have to go for the life cycles. So if those cycles are known to you, it's very quite easy to solve this problem. Oxidative decarboxylation, glycolysis process, oxidative phosphorylation, tricarboxylic acid cycle. So these are the column 1 options. Citrate synthase, and these are said to be either pathway or enzyme used for the reaction. Pyruvate dehydrogenase, electron transport system, EMP pathway. So which is suitable for what kind of option? We will go with one by one, right? So C will be the correct explanation. Let's see what is the process. Oxidative decarboxylation. Here, oxidative decarboxylation is proceeded with the dehydrogenase, right? So in this dehydrogenase, what dehydrogenase? Pyruvate dehydrogenase is the enzyme employed over here. Oxidative decarboxylation can be accompanied with the pyruvate dehydrogenase, so that A will be mapped with option number 2, right? So from this mechanism, it is very clear. Let's go with the second one, glycolysis. So glycolysis means cleavage of the glucose is called glycolysis. Whenever glucose is taken and added with adenosine triphosphate converted into ADP. So whenever adenosine triphosphate to ADP, one of the phosphate will be excluded and added with the glucose, so that glucose will be converted into glucose 6-phosphate. And glucose can be morphalized in the presence of isomerase. Isomerase is the enzyme used to convert glucose into fructose, so that glucose 6-phosphate converted into fructose 6-phosphate. Later on, again ATP molecule, ATP is the source of energy, can be added. Here TP means a triphosphate. Later on converted into ADP means one of the phosphate got released, so that this fructose 6-phosphate now converted into bisphosphate, means another phosphate is also added to the fructose, so that 1,6-bisphosphate will be generated. Later on, aldolase is the enzyme which able to convert the molecule into GLAP. GLAP can be hydrolyzed in the presence of hydrogenase, and bis phosphoglycerate will be. So initially we have glucose followed by fructose, and here glycerate molecule will be generated, and that can be treated with glycerate kinase enzyme, so that phosphoglycerate. So here bisphospho can be converted into monophospho, because it binds with ADP, so that one of the phosphate got absorbed, and ADP, adenosine diphosphate, now converted into adenosine triphosphate by taking one of the phosphate, so that we will get a 3-phosphoglycerate. Again, mutase can be added. Whenever mutase is added, the position of phospho is shifted from third to second. And enolase means ketoenol tautomerism will be carried. Glycerol is now turned into pyruvate. So finally, that another phospho group is there, that also removed by ADP, so that finally the product will be pyruvate. This is the mechanism for the conversion of glucose into pyruvate by the mechanism called EMP pathway. This is called EMP pathway, so that glycolysis is proceeded with the EMP pathway. And next, let's move on to another mechanism. Electron transport chain is accorded for oxidative phosphorylation. So this is the mechanism proceeded with electron transport chain, right? So here in this electron transport chain, what we are producing is adenosine triphosphate is generated. This is the oxidative phosphorylation mechanism, right? Phosphates will be added over here, and final product will be adenosine triphosphate. Okay, so that will be started with NADH, and there is a kind of series of reactions, and finally ATP will be generated through the process of electron transport chain, right? Electrons will be shifted from one place to another place by oxidative phosphorylation process, right? Oxidative phosphorylation can be mapped with the electron transport mechanism. And let's see the D. D is given as the tricarboxylic acid cycle, right? So this is the cycle where you can see citric acid pathway will be proceeded, where tricarboxylic acid cycle will be there. So that for the option number D, tricarboxylic acid cycle, you can map with the citrate synthase, right? Oxidative decarboxylation is the pyruvate dehydrogenation. Pyruvate dehydrogenase enzyme is required. Glycolysis requires EMP pathway. Oxidative phosphorylation proceeded with the electron transport mechanism. Tricarboxylic acid cycle, citrate synthase is required. For question number 4, option number C will be the correct answer. Let's move on to question number 5. It is taken from the EAMCET examination conducted in Telangana. Which of the following option is true, right? 4 options are provided over here. Stannic tetrafluoride is ionic. Sn can be exist in +2 and +4 oxidation state around the central tin. So that here you can see Sn +4. So that we can say stannic. Stannic tetrafluoride is ionic. Lead tetraiodide can be prepared. Carbon tetrachloride undergoes hydrolysis. Germanium tetrabromide is less stable than germanium dibromide. These many options, among all only one option will be the correct answer. We have to find out, that is tin tetrafluoride is ionic. This is the correct answer. Let's see why it is correct answer. So let's compare tin tetrachloride and tin tetrafluoride. Tin tetrachloride, if you consider, chlorine is lesser electronegative compared to the fluorine, so that here the bond polarity is least. Here bond polarity is larger in case of tin and the fluorine. Fluorine is more dragging electrons more strongly towards the fluorine atom, being it is more electronegative, so that you can accord the ionic nature, transfer of electrons rather than mutual sharing. And here tin tetrachloride, there is a mutual sharing of electron among tin and chlorine are possible. And one more thing is, tin +4 easily polarized chloride. Chloride ions easily polarized by the tin, so that there is a kind of overlapping, covalent overlapping is noticed. Whereas tin can't polarize the fluoride ion. Polarization may not be possible. This polarizability can be explained by the Fazan's rules, and that is not appeared in tin tetrafluoride, so that we can say it is ionic in nature. And the second factor is electronegativity. So here electronegativity difference between the tin and fluorine is highest. Being fluorine is more electronegative atom, we can say this is a polar bond, and that used to get transfer of electrons rather than mutual sharing, so that tin fluorine bond is ionic, more polar and ionic in nature. Tin chlorine is a covalent in nature. That's why tin tetrafluoride is purely ionic in nature. In another statement what they provided is lead tetrabromide, lead tetraiodide. The possibility of the formation of lead tetraiodide or bromide is not possible because whatever lead plus 4 is there, immediately it got converted into Pb plus 2 because Pb plus 2 will be more stable oxidation state around the central tin rather than tin plus 4. And being bromine and iodine are more tendency to oxidize, so that plus 4 easily converted into plus 2 form. That's the reason why existence of tin tetraiodide is not possible in practical sense. Rather, tin dibromide, sorry, lead dibromide or lead diiodide are the prominent products we can assume. And another one is carbon tetrachloride undergo hydrolysis. Let's see the explanation. Carbon tetrachloride is not hydrolyzed. There are two reasons in order to explain the not possibility of hydrolyzation of carbon tetrachloride. One of the thing is carbon may not have the d orbitals in its valency shell. Carbon atomic number is 6 and electronic configuration is 1s2, 2s2, 2p2. That's it, right? So that d orbitals are not available, so that electrons can't be accepted into the vacant d orbitals from water molecule. That is the first reason. And second is being chloro around the carbon are larger in nature. They can't accommodate water molecules inside in order to retain the electrons from the water. These chloro are bulkier in nature, can't provide the way to get electrons to share with the carbon atom, so that they are not giving a way to the water to get reactive with this carbon. Being chloro or shielding, this is called a shielding effect. Shielding effect of chlorine atoms are larger in nature. That's why water hydrolysis may not be possible. So many factors operated in CCl4 hydrolysis process, so that we can't hydrolyze CCl4. Being carbon is 2s2, 2p2, d orbitals are missing, so that electrons want to be accepted. First reason. Second is being chloro are the larger, so that there is no pathway to reach the electrons into the carbon atom. And third is shielding effect of carbon is larger, that used to get the protective shield around the sphere of carbon tetrachloride, so that a water molecule can't enter inside to release the electrons. These many factors can make CCl4 is not able to get the hydrolysis process. Let's go with the another one, germanium. Germanium tetrabromide, germanium dibromide, they are saying about. So germanium tetrabromide is less stable compared to germanium dibromide. This is the wrong statement because germanium is the member of carbon family and outer electronic configuration resided with Ns2, Np2. Ns2 is 4s2, Np2 is the 4p2. 4s2, 4p2 electrons are the valency electrons. Being 4 electrons available for the bond formation, germanium is preferably participate in the tetravalency rather than divalency. So that germanium upon treating with the bromine of 2 moles, so that germanium tetrabromide will be generated. So it will be more stable. Being its valency of germanium is 4, germanium tetrafluoride is more stable comparison with the germanium difluoride. So that option number 4 is the wrong one. Only the correct answer is tin tetrafluoride is ionic in nature because fluorine is more electronegative. There is a greater electronegativity difference among tin and fluorine, so that the bonding between the atoms becomes transfer of electrons. So we can say it is ionic in nature. Move on to the last question of the session. The acidity of the soil can be reduced by some of the acidic soils will be there, some of the basic soils, some of the neutral soils will be there. Here the condition is acidic soils are taken. If the soil is acidic, that is not susceptible to grow the crops. All kind of crops not able to grow in that type of soil. That's why we have to neutralize the acidic nature. In order to neutralize, what will be the suitable chemical required? Sprinkling of dilute sodium hydroxide, spraying of carbon dioxide dissolved in water, adding powdered limestone, adding powdered sodium carbonate. Which is preferable? We have to check it out. So among all, the correct answer is adding powdered limestone. limestone if added. So here you can clearly observe agricultural limestone is available where soil nature is acidic. Acidic means pH is less than 7 if present, then only we can say soil is acidic in nature. Acidic soil can be neutralized conveniently by adding base. What base? Limestone base. So this is the commercially available limestone. You can mix up with the soil so that we can rise the neutrality of the soil, and it is preferable to grow the croplands. What is the reason? Rising the soil pH with lime. Whenever lime added to water, the free release of calcium plus 2 bicarbonate and OH minus is possible, right? Whenever these kind of ions are released, here you can clearly observe OH minus. OH minus when added, soil acidic nature get neutralized, and moreover, whatever ions are there, acidic ions are there in the soil, get treated with calcium carbonate and water so that the calcium ions retained with the soil, and this aluminum hydroxide, carbon dioxide, water will be discarded. So there are limiting agents. So there are limiting agents other than calcium carbonate. So calcium carbonate is very convenient to use, neutralize the acidic nature of the soil, so that adding powdered limestone is very sufficient to destroy the acidic nature of the soil. For question number 6, option number 3 will be the correct explanation. By this, we completed the entire session containing all the questions of previous year examinations, and the proper explanation is also provided. Hopefully, this will be helpful for your further preparation, and whatever you are aspiring for, that will be definitely cracked if you are following this carefully. And I'm requesting you to kindly like the channel, comment over what kind of things you are mostly interested about, which thing in this video is very much helpful for you, that you can comment over here, and share with your friends whoever aspiring for any entrance exam or competitive examination, and subscribe the channel in order to get more updates regarding the concepts for entrance and competitive exams. Thank you very much for your patient listening. Thank you, one and all.